All right, so just a little review of our different intermolecular forces. First, we have dispersion forces. All molecules and atoms have this, and it's the weakest one, between 0.05 to 20 kilojoules per mole. Then dipole-dipole, which is between polar molecules, and that's about 3 to 20 kilojoules per mole. And then finally, hydrogen bonding, which is just molecules that contain a hydrogen bonded to fluorine, oxygen, or nitrogen, and that has 10 to 40 kilojoules per mole of energy. So another thing to remember is that intermolecular forces are much weaker than intramolecular forces, which are bonds. So for example, an HH bond is 436 kilojoules per mole. So still much stronger than any of these other ones. Another thing you'll notice is that this dispersion has a little asterisk next to it. And that's because although dispersion forces are the weakest, you can have a whole lot of them. If you have a huge, huge molecule, even though it's nonpolar, it can have so many dispersion forces that it actually has a higher boiling point than something else. So when we say that hydrogen bonding is stronger than dispersion forces, we really mean of molecules of relatively the same size. So let's do some examples. So which one of these has the higher boiling point? So let's do N2 versus HCl, CH3O, CH3 versus CH3, CH2, OH, or neon versus helium. So go ahead, take a second and let me know which one of these has the higher boiling point and why. All right, so hopefully you've taken a look at these and figure out which one has the higher boiling point and why. So first we have N2 versus HCl. So the first thing we notice is that N2 is the same atom, so it's the same electronegativity, so it's going to be non-polar, while HCl is polar. And so HCl can have dipole-dipole intermolecular forces, which will keep it together more and thus have the higher boiling point. Next, we have CH3O, CH3 versus CH3, CH2, OH. We notice that this oxygen is not bonded to any hydrogen, so it can't have hydrogen bonding, whereas this one is bonded to a hydrogen, so it can have hydrogen bonding. And since hydrogen bonding is the strongest intermolecular force, it's going to result in the highest boiling point. Next up, we have neon versus helium. If we take a look at our periodic table, we know going down, we get bigger. So helium is smaller than neon. And remember, so neon is bigger. And so the bigger you are, the more polarizable you are, the more dispersion forces you have, and thus the higher boiling point.